Hello class 12 science students. Now today we are going to discuss the last topic of this chapter, Banter Factor. We already discussed about the four colligative properties, and we have also seen the numerical based on it. Now we'll see the last topic, that is Banter Factor. So before that, let us try to understand what is abnormal molecular mass. Before this, in the colligative properties, in the numerical, we calculate the molecular mass of the solute. So what does abnormal molecular mass means? We have discussed that the colligative properties help us to calculate the molar masses of solutes. The accurate values of molar masses can be obtained only if the accurate value of molar masses or molecular mass can be obtained only if the solutions are dilute, and number two, the solute must not dissociate or associate in solutions. This thing, number two condition, is very important. So differences in determination of molar mass arise when the solid dissociate or associate on dissolving in a solvent. As colligative properties depend only upon the number of particles, this comes from the definition of colligative properties, they are expected to show certain deviations which in turn influence the molecular masses. So as the colligative properties depends only on the number of particles, if there is certain deviations, so it will affect the molar masses or molecular mass. The discrepancy in molar mass is called abnormal molar mass. So we have got a factor known as Banter factor. Banter in 1886 introduced a factor called Banter factor to express the extent of association or dissociation of solutes in solution, and it is defined as the ratio of observed or experimental colligative property and normal or theoretical value of colligative property. So I will be given by observed or experimental colligative property divided by theoretical or normal colligative property, or I is equal to normal or theoretical molecular mass divided by observed or experimental molecular mass. This is the definition of I Banter factor. So when you introduce this I term, then the colligative properties inclusion of Banter factor modifies as number one, delta P by P naught. This is the relative lowering of vapor pressure equals to I into mole fraction of the solute. Number two, delta TB equals to I into KB into M. Delta TF equals to I into KF into M, and phi equals to I into CRT. So in all the equations we have just placed I, that is Banter factor, there. Now we will do the numerical based on this Banter factor, which has come in the past ISC. So numerical on Banter factor, this will be your assignment 25, and this will be your last assignment for your third card test. So formula to be used, all this thing formula. Now based on this formula we are going to solve the numerical. First numerical, question number 1. In this, the osmotic pressure of 0.01 molar solution of an electrolyte is found to be 0.65 atmosphere at 27 degrees Celsius. This is 27 degrees Celsius. Calculate the Banter factor. What conclusion can you draw about the molecular state of the solute in the solution? So first you will write down the calculate the Banter factor and what conclusion can you draw from the molecular state of the solute in the solution. So first you will write down the given. So osmotic pressure is given 0.65 atmosphere. The concentration is also given 0.01 molar. The value for R is known to us, 0.0821. We missed over here 821, and okay, 0.0 to 821. Now T is equals to the temperature. We have to express in Kelvin. 27 plus 273 will give you 300 Kelvin. We know, since we have used the osmotic pressure, we need to use the Banter factor involving osmotic pressure. Phi equals to I CRT. Substituting 0.65 equals to I into 0.01 into 0.0821 into 300. So from this we'll get the value for I equals to 0.65 divided by 0.01 into 0.0821 into 300 equals to 2.639. So the value for I Banter factor will come as 2.639. Now from this value of Banter factor I, we can see that as the value for I is greater than 1 in the above case, it tells us that the electrolyte is an ionic compound and undergo dissociation in solution. Got it? Since the value for I is greater than 1, it will undergo dissociation. If the value for I is less than 1, then it will undergo association. That is the thing. So for this, the numericals that you need to do as an assignment are: question number 2, the freezing point of a solution containing 0.3 gram of acetic acid in 30 gram of benzene lowered by 0.45 Kelvin. Calculate the Banter factor. What else is given? Atomic weight of carbon, hydrogen and oxygen is given, and the value for Kf, that is cryoscopic constant for benzene, is given as 5.12 Kelvin kilogram per mole. This question has come in the year ISC 2013. In question number 3, a 2 molar solution of sodium chloride in water causes an elevation in the boiling point by 1.88 Kelvin. What is the value for Banter factor and what does it signify? So you need to calculate the value for I, and from that value I, you need to identify what does it signify. And the boiling point molar elevation constant is given 0.52 Kelvin kilogram per mole. This question has come in the year ISC 2014. Solve this assignment and send it to my mail.